Welcome to Campus Papers. This is paper 2, variant 2 for IGCSE Chemistry, October-November 2023. This is part 1, covering questions 1 to 20. Let's begin. Question 1. Part of a cooling curve of water is shown. I have a diagram here. What is occurring between point X and Y? Now, if you look at point X and Y, it's a flat line showing us energy change and not temperature change. Please take note. Energy change. This is energy change and not temperature change. So that means our answer is going to be A. Steam is condensing into water. That's wrong. The temperature of the water is decreasing. No, that's wrong. What's happening here is energy change, not temperature change, because it's a flat line. Ice is melting. Wrong. Particles are losing heat to the surroundings. Correct. So D is our correct answer. And the reason why D is our correct answer, not B, is because during a phase change, temperature stays constant. It's only energy that is changed. Question 2. Which statement about clean, dry air are correct? It is a mixture of elements only. That's wrong. It is a mixture of elements and compounds. That's correct. It contains only non-metals. That's correct. So our answer is C, which is 2 and 3. Question 3. A representation of an atom is shown. This is what we have. What is the nucleon number of this atom? Now, nucleon number is the number of proton and neutron in the nucleus of an atom. So what we are doing is this is the nucleus of an atom, for us to count the number of protons and neutrons here. So when you count everything here, it's going to give you D, that thing. Question 4. The percentage abundance of 3 isotopes in a sample of neon are shown. So this is what we have. What is the relative atomic mass of this sample of neon? So how do we calculate this? We multiply each isotope by percentage abundance, and then we divide everything by 100. So this is going to be 20 multiplied by 90.48 plus 21 multiplied by 0.27 plus 22 multiplied by 9.25. Divide everything by 100. And to press your calculator, our answer is going to be B, which is 20.19. Question 5. Potassium reacts with iodine to form potassium iodide. Which statement about potassium iodide is correct? A. Each potassium atom shares a pair of electrons with an iodine atom. Now, to answer this question, we need to write our formula for potassium iodide, which is, so you check your periodic table to see the group that potassium belongs to. Potassium is in group 1, so that means it has 1 electron in the outer shell, so the balance is going to be 1. We check iodine, which group does it belong to? Iodine is group 7. That means it needs 1 electron to complete its shell, because you have 7 electrons in the outer shell, so this is negative. So let's go to the option again. Each potassium atom shares a pair of electrons. Now this is an ionic compound. How do I know? Between a metal and a non-metal, positive and negative. So there's no sharing of pair of electrons, so A is out. B. In potassium iodide, the particles of potassium have more protons than electrons. Yes, this is correct, because potassium will give out 1 electron to iodine, so that means to have more protons than electrons, because it loses 1 electron. So our answer is B. And then let's check C and D. Potassium iodide has a high melting point because it is a covalent compound. No, it is an ionic compound. Potassium iodide has a low melting point because it's ionic compound. No, it will have high melting point since it is an ionic compound. So D is wrong. So our answer is B. Question 6. Which substance has the lowest melting point? So we are looking at graphite. Graphite has high melting point. It is a giant covalent structure. Then methanol. Methanol will have a low melting point. It's an alcohol with a short chain, just 1 carbon. So it will have the lowest melting point. Now let's look at others. Silicon dioxide is a giant structure to have high melting point. Sodium chloride is an ionic compound to have high melting point. So correct answer is B, methanol. Question 7. The diagram shows the structure of a molecule of ethyl ethanoate. This is an ester. What is the molecular formula of a molecule of ethyl ethanoate? So molecular formula is simple. Just count the number of carbon, hydrogen, and oxygen. That's all. So here we have 1, 2, 3, 4 carbon, so it's going to be C4. And then we have 1, 2, 3, 4, 5, 6, 7, 8 hydrogen, H8. Then we have 1, 2 oxygen, O2. So our answer is B, C4H8O2. That is how you write molecular formula. Question 8. A hydrocarbon contains 85.7% of carbon by mass. What is the empirical formula of the hydrocarbon? So to calculate our empirical formula, we divide our percentage by relative atomic mass. So here it is a hydrocarbon, that means it's hydrogen and carbon. So we have our carbon and then we have our hydrogen. Now the percentage of carbon is given to us, which is 85.7, but that of hydrogen is not given to us. So we need to find that. How do we do that? You just do 100 minus 85.7, which is going to give us 14.3. So now you divide it by the relative atomic mass. The relative atomic mass of carbon is 12. Confirm for a periodic table. This is carbon. Look at it here, 12. So we divide it by 12. Hydrogen is 1, so we divide by 1. So 85.7 divided by 12 give us 7.142, while this one 14.3 divided by 1 is 14.3. So you divide them by the smallest. The smallest is 7.142, so divide through by 7.142. So 7.142 divided by 7.142 gives us 1, and then 14.3 divided by 7.142 is going to give us 2. So therefore our empirical formula will be carbon is 1, which is C, and then we have 2 hydrogen. So our formula is CH2, which is A. So the answer is A, CH2. That's how you calculate empirical formula. Question 9. The formula of a compound containing element X is the relative formula mass of the compound is 158. What is the relative atomic mass of X? So in order to do that, this relative atomic mass is the sum of the relative atomic masses of individual elements here. So what we are going to do is we check the relative atomic mass of sodium, which is from our periodic table. Sodium is 23. It's going to be 23 multiplied by 2 plus X2. We don't know what that's what we are looking for. Oxygen, related to atomic mass of oxygen is 16. It's going to be 16 times 3 since we have 3 oxygen here. Everything now will be equal to 158. So this will now be equal to 23 multiplied by 2, 46, plus X2 plus 16 multiplied by 3, that's 48. Everything will be equal to 158. Now we'll collect like times, so we 46 plus 48, which is 94. Next, 94 will cross the equal sign, return to minus, so it's going to be 158 minus 94. So our x2 therefore is going to be equal to, our x2 therefore is going to be equal to 64. But what we are looking at is the relative atomic mass of X, not X2. So we divide both sides by 2 so that we can get relative atomic mass of X. Our X will therefore be equal to 64 divided by 2, which is equal to 32. So our answer is A, 32. Next question. Dilute aqueous potassium chloride is electrolyzed using platinum electrode. Which row identifies the product at each electrode? So we have dilute aqueous. So whenever you hear dilute aqueous, you know that at your anode, oxygen will be the product at the anode. So that means our answer is between C and D. Then it is aqueous potassium. So that means it is not potassium that will be at the cathode, that will be produced at the cathode. And it is aqueous potassium chloride. So which means that it is hydrogen that will be produced at the cathode, not potassium, because hydrogen is less reactive than potassium. So the answer is going to be C, oxygen at the anode and hydrogen at the cathode. Next question, question 11. Concentrated aqueous copper 2 chloride is electrolyzed using copper electrode as shown. What happens to the mass of each electrode during this process? Now you are using copper electrode. Copper electrodes are not inert, so they are going to participate in the reaction. So you expect the copper from the positive electrode to be attracted to the negative. So that means the positive will reduce in size because the copper will move from that place, positive to the negative, thereby the mass of the negative will increase. So let's look at our option. Option A, positive electrode decreases. Yes, the answer is between A and B. Positive electrode decreases, then the negative electrode increases. So answer is B. So because the copper electrode is not inert, to participate in the electrolysis, positive copper ions will move to the negative electrode, therefore decreasing the size of the positive electrode and increasing the size of the negative electrode. Question 12. The initial and final temperatures of 4 different reactions are measured. Which reaction is the least exothermic? So exothermic reaction, energy is released to the surroundings. So when we are looking at the least exothermic, that means the one that releases the least energy. So how do we know that? We do final temperature minus initial temperature. So let's start with option A, 25 minus 19, that will be 6 degrees Celsius. 18 minus 21, that will be minus 3. 17 minus 22 minus 5. And then 26 minus 22, that will be 4. So that means our answer is between A and B because they are the exothermic. B and C are endo, energy is absorbed. That's why we are having negative sign. So between A and B, which one releases the least amount of energy, or which reaction is the least exothermic? So our answer is 4. 6 is greater than 4. So that means our answer is D. Question 13. Which equation represents an endothermic reaction? So endothermic reaction, energy is absorbed. So we are looking at a reaction that does not release energy to the surrounding, but rather absorb energy to the surrounding. So automatically our option B is out because option B is burning, so it's exothermic. And look at option A, it is bond breaking. You are breaking the bonds between these two chlorine. So, and in bond breaking, energy is absorbed. So that means that our answer is A. Now let's look at C. C is bond formation because hydrogen and hydrogen to give you this hydrogen gas bond formation. So therefore, it is exothermic. Question 14. Methane bonds in oxygen to form carbon dioxide and water. This is the equation of the reaction. The bond energies are shown. This is our bond energy. What is the energy change for this reaction? So to calculate the energy change, we use bond broken minus bond formed. That is reactant minus product. So we need to calculate our bond energy of the reactant and then bond energy of the product before we subtract them. In order to do that, we need to write this equation in a displayed formula. So our methane, CH4, is our oxygen, two oxygen bonded together. They will share 4 bonds, a double bond, and we have 2 of it. So we'll put 2 here. Our product, we have carbon dioxide, CO2, and then we have water, and we have 2 of it. So for you to be able to draw this display formula of this reaction, you have to know your covalent bonding very well. Okay, so now let's check the bond energies of each bond, and then we can get the bond broken energy and the bond form, and then we subtract them. So carbon to hydrogen bond is 410. That means anywhere we see this is 410. So if you look at that methane, we have this carbon and hydrogen, that's 1, carbon and hydrogen 2, carbon and hydrogen 3, carbon and hydrogen 4. So it's going to be 4 multiplied by 410 plus our oxygen to oxygen double bond is 496, and we have 2 of it, so it's going to be 2 multiplied by 496. So for our product, we have carbon oxygen bond. This is carbon oxygen bond, and it's 805, and we have 2 of it, carbon oxygen 1 and then carbon oxygen 2. It's going to be 2 multiplied by 805 plus we have oxygen hydrogen bond, which is 460, and we have 2 of it, oxygen hydrogen, that's 1, then oxygen hydrogen, that's 2. It's going to be 2 multiplied by 460, but then we have 2 of it, 2 of oxygen hydrogen, oxygen hydrogen, so multiply everything by 2. So this is 1640 plus 992, that's for the reactant. So let's go to the product. 1610 plus 1840. So we add this, and then we subtract them. So it's going to be 2632 minus 3450, which is going to be equal to minus 181. So therefore, our answer is A. So this is how you calculate the energy change for this type of reaction. Question 15. Hydrochloric acid is added to excess calcium carbonate in 2 separate experiments. 2 different concentrations of hydrochloric acid are used, but the temperature is the same in both experiments. The graph of the result shows the volume of carbon dioxide gas given off over time. So this is our graph showing us the different concentrations. Which row is correct? Particles in 2.0 mole per dm cube compared to particles in 1.0 mole per dm cube. So we are comparing their concentration. Take note of that. So A, collision rate higher. Yes, collision rate in 2.0 mole per dm cube will be higher because the concentration is higher. That means the answer is between A and B. So let's look at this column to differentiate which is the correct answer. Collision energy. No change, yes. There should be no change in collision energy. Why is there no change in collision energy? This is because energy depends on temperature, not concentration. And if you look at the question here, we are told that the temperature is the same for both experiments. So since the temperature is the same for both experiments, that means the collision energy is going to be the same. Concentration only affects the frequency and not the energy. So therefore, the collision energy, for collision energy, there's not going to be any change. So that's why A is the answer. Question 16. The decomposition of dinitrogen tetroxide into nitrogen dioxide is a reversible reaction. The equation for the reaction is shown. This is it. The forward reaction is endothermic. Take note of that. Which row shows the effect on the position of equilibrium and the rate of reverse reaction when the temperature is increased. So already here, we are told that the forward reaction is endothermic. So since the forward reaction is endothermic, when we increase temperature, the equilibrium will shift to the right, which means that reverse rate increases. Why would the equilibrium shift to the right? Now, the forward reaction is endo, that means to the right. So, and we say that when there's change in equilibrium, the equilibrium will try to oppose the change. So you are increasing temperature. So the equilibrium will try to absorb the energy that you are adding. So therefore, the equilibrium will move to the endo. Endothermic means absorbing energy. So it will move to the endo to absorb that energy increase due to the temperature increase. Okay, so that means the equilibrium will shift to the right. Remember, this is your left and this is your right. And our right is the forward reaction, which is endo. So the equilibrium will shift to the right. And when the equilibrium shifts to the right, the reverse rate will therefore increase. So that means our answer is going to be D. Equilibrium shift to the right, rate of reverse reaction increases. So don't forget, increase in temperature favors endothermic direction. Question 17. In a blast furnace, iron 3 oxide is converted to iron and carbon monoxide is converted to carbon dioxide. We have a question of the reaction here. What happens to each of these reactants? Both iron 3 oxide and carbon monoxide are oxidized. No, they are not both oxidized. Look at the equation of the reaction here. Iron 3 oxide loses oxygen to become iron, while carbon monoxide gains oxygen to become carbon dioxide. So it cannot be all oxidized, but rather iron 3 oxide is reduced because oxygen is removed, and then carbon monoxide is oxidized because oxygen is added. So let's look at that option. That would be option D. The answer is D. Iron 3 oxide is reduced from this to this, and then carbon monoxide is oxidized from this to this. Question 18. Which row describe what happens to two ions when they are oxidized? So we need to remember the definition of our oxidation and reduction using oil rig. Oxidation is loss of electron, reduction is gain of electron. So this two ions will oxidize, it loses electrons. So therefore, our answer is going to be between C and D. They lose electrons. Then oxidation number of ion. The oxidation number of ion also increase. So therefore, our answer is going to be D. They lose electrons. Oil rig. Oxidation is loss of electron. And we said that they were oxidized. Then oxidation number, since they were oxidized, oxidation number will increase because increase in oxidation number means that an atom is oxidized. Question 19. In which reaction does an acid react with a base? So A, dilute sulfuric acid is added to a piece of magnesium ribbon. That is wrong. Magnesium ribbon is a metal, not a base. Dilute sulfuric acid is added to aqueous barium chloride, producing a white. Aqueous barium chloride is a salt, not a base. C, aqueous sodium hydroxide is added to aqueous copper 2 sulfate, producing. This is not an acid. So we are talking about in which reaction does an acid react with base. Sodium hydroxide is a base. Copper 2 sulfate is not an acid, it is a salt. So C is wrong. Then D, aqueous sodium hydroxide is added to a solid ammonium sulfate, producing gaseous ammonia. That is correct. Why? Because sodium hydroxide is a base and ammonium sulfate is an acid. Question 20. Which element forms an oxide that reacts with an aqueous solution of a base? That means we are looking for acidic oxide. Now, acidic oxide are oxide of non-metal. So obviously A is wrong because argon is a group 8 element and they do not react. So A is out. Then B is correct answer. Sulfur is a non-metal, so it will form an acidic oxide that can react with pH. C is wrong. Magnesium is a metal. And then D also is wrong because copper is a metal. This brings us to the end of part 1, covering question 1 to 20. See you in part 2, covering question 21 to 40. Don't forget to like, subscribe, and share.